In this video, we'll go over how to do the problems from Monday, April 13th. And we're talking about thermodynamics still. So the first topic we're going to talk about is heat exchange and entropy. Remember, this delta S is entropy. And just a reminder of what heat exchange means. So if a process loses heat, it's exothermic. So if a system loses heat, that heat has to go to the surroundings. Now, when something gains heat, entropy or chaos increases. So an exothermic process increases the entropy of the surroundings. While an endothermic process, that will take heat from the surroundings into itself. Since you're taking heat away from the surroundings, you are lowering the entropy. And we can relate entropy to temperature to determine the change of entropy. So if you look at this equation, you can see that enthalpy and temperature, if you divide the two, that's how you get entropy. And that kind of makes sense, right? So if I just add 1 kilojoule of heat to a room that's 0 degrees Celsius, that has a much bigger effect than if I added the same amount of heat to a room that was already like 500 degrees Celsius. So that's how heat and temperature are related to entropy. So our first question is using this equation. So calculate delta S surrounding for the temperature and determine if it's exothermic or endothermic. So I have A here, and we're looking at enthalpy of reaction. So remember, H is enthalpy, that means heat. So our reaction is losing 386 kilojoules of energy. If enthalpy is negative, that is exothermic. All right, now let's look at the change of entropy of our surroundings. So our change in entropy is negative delta H. So our delta H was already negative, so it's negative times negative 385 divided by our temperature. So this is really positive 385 divided by 298. And when you get that, you should get 1.29 kilojoules per Kelvin. So the entropy increased, which it should, because we are releasing heat from our system into our surroundings. So that's how you use that equation. In talking about entropy, we can determine if a reaction is spontaneous or not due to the entropy of the universe. That is, a reaction will only happen if the chaos of the universe or the entropy of the universe increases. And we can look at that for ice freezing. So here is high temperature. So here's our temperatures above 0 degrees Celsius. Now, when we freeze ice, you are taking heat from water and giving it to its surroundings. Heat is leaving the water to become ice. At high temperature, the change in delta S surroundings isn't that much. Based on the equation we just talked about in the previous slide where we're dividing by T, the higher the temperature, the lower the change in delta S surroundings. To get the entropy of the universe, you just add the entropy of the system plus the surrounding, because the universe is everything. And so here, at high temperatures, the entropy of the universe is negative. Negative entropy processes don't happen. So water does not freeze at high temperatures. It's non-spontaneous. However, at lower temperatures, the change in delta S surrounding is much greater. So now delta S universe is positive. That's a spontaneous process now. Right? So we're going to use those ideas with our previous equation to determine if a reaction is spontaneous. So I have A for us. So we have delta H reaction and delta S reaction. So when I say reaction, that's the same thing as system. So reaction and system are the same thing. So I already have one piece. I have delta S system, which is delta S reaction. So delta S system is negative 263 joules per Kelvin. let's do delta S surroundings. So I do negative delta H was positive, so negative 115 kilojoules divided by our temperature, which is 298, to get negative 0.386 kilojoules per mole. Now you can see that my delta S is in joules, and what I just calculated was in kilojoules. So they need to be in the same unit. So what I did is I converted my kilojoules to joules. So that's 386 joules per Kelvin. I just multiplied this by 1,000. Now I can calculate delta S universe, which is delta S system plus delta S surroundings. So system, negative 263 minus 386, which is negative 649 joules per Kelvin. So in A, entropy of the universe is negative, which means non-spontaneous. So if it's positive, spontaneous, negative, non-spontaneous. And when we talk about reactions that are spontaneous or not, we don't really look at entropy of the universe because that's really hard to measure. What we do is we look at Gibbs free energy, because all we're worried about with Gibbs free energy are systems. So delta G of a system equals delta H system minus T times delta S system. This is the Gibbs free energy equation. And for Gibbs, if delta G is negative, that means that reaction is spontaneous. If delta G is positive, non-spontaneous, delta G is 0, then equilibrium. So here's a table just looking at how we can calculate delta G with our table here. So for example, in our first row, if delta H is negative, so negative here, and delta S is positive, but there's one thing that trips up people. This is negative T delta S. So we have to look at this as a giant term. If delta S itself is positive, that means this whole term is negative. So delta H is negative, minus T delta S is negative. Negative and a negative will always give you a negative delta G. As delta G is always negative no matter what, this means that this process will always be spontaneous no matter what temperature we are at. So that's why at high temperature, and that's also why at low temperature we have spontaneous. Now let's look at our next situation. Delta H is negative, delta S is negative, which means minus T times a negative delta S. My minus T delta S term is actually positive. So we have a negative and a positive. That means delta G is temperature dependent. Alright, so at low temperatures, when T is small, that means this positive term will get smaller and smaller and smaller. Delta H is negative, so this will dominate, the delta H term will dominate at low temperatures, so it's spontaneous. At high temperatures, this T gets higher and higher and higher, which means this positive term gets bigger, 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 and it'll be bigger than our negative delta H term. So positive will dominate. Delta G will be positive at high temperatures. That's non-spontaneous. For the third column, where we have a positive, positive, it's the same idea I just said for the second column, but the logic's just flipped. And for our fourth row, I think I said column before, but for our fourth row, where we have a positive delta H and negative delta S, our logic is flipped from our first row. So see if you can logic that out of how we get that, how this makes sense. If you don't, please feel free to email me with questions. I can help to answer that. Our last problem for today is actually calculating delta G. So delta G equals delta H minus T delta S. So if delta H is 115 kilojoules and delta S is negative 263 joules per Kelvin, T is at 298, calculate delta G and tell me if it's spontaneous or not. So plug in my value for delta H, 115, minus 298 times, so here is our problem again. Delta H is in kilojoules, delta S is in joules. Both of these need to be in the same unit. So what I did is I took delta S divided by 1,000 and now it's in kilojoules. So multiply 298 by negative 0.263. I get 115 plus 78.37 equals 193.73. My delta G is positive. Positive means non-spontaneous. And with that, that's the end of this video. Please let me know if you have any questions about anything. Otherwise, I'll see you in the next video.